This is a follow-up to the multi-voltage power supply video as a result of an appreciated comment. First off, I have to determine where the noise is coming from before adding a solution. I'll check the AC to DC power supply first and monitor the output with an oscilloscope. The first test will be for ripple and noise with the current 36 volts and no load. The second test will be with a small load to observe if the ripple and noise increase. I only have a 100 ohm 25 watt resistor for the load, and I'm hoping that will be enough. Testing is showing that the AC to DC power supply is noisy with and without a load. I did some investigation and found this article from Analog Devices that looks to be helpful. I've put the link in the description. It suggests that filtering can be added to the output of a switching power supply to help minimize the noise. I'm going to go with an LC filter and purchased a 10 microhenry inductor and a 470 microfarad capacitor to see if these would clean up the output. With the filter connected, I'll do the two tests again. With this configuration, both of these tests look better. I added a 47 nanofarad decoupling capacitor at the power supply output, and then the LC filter will follow. The results look slightly better, so I'll leave it in place. Before I start to disassemble the built power supply, I'm going to test another buck-down converter on this breadboard. The reference website also indicates that the input of the buck converters may be the cause of the noise as a result of the device's on-off switching action. I tested this option but found that the test results were worse, so I abandoned it. I have the AC to DC power supply output and the buck converter input connected to the breadboard. There is no load in this test. I measured the input noise and then the output noise. I will add the 100 ohm load and look at the input again, and then measuring the output. I will do the same two measurements again, only with the buck converter's output set at 30 volts with no load, and the 30 volt output. And like before, I'll add the load and do the measurements again. Now that I have a baseline, I will add the LC filter to the output of the buck-down converter and then go through all 8 tests again. You've noticed that 6 of the 8 tests show positive results using the LC filter on the output. Just as a reminder, don't forget to subscribe. Click like if you do, and the notification bell for new videos. And if you have comments, please leave them below. I think it's safe to say that we can modify the built power supply. I added the LC filter to the output of the AC to DC converter. I also added the LC filters to the output of the buck-down converters. I tested the output of the original power supply design, and the LC filter modifications have greatly reduced the amount of noise on the DC voltages. That said, the buck-down converters are far from ideal, and suspect that when taxed with static and dynamic loads, noise will increase. The adjustable power supply module, however, seems to be a much better design and trends better when load is applied. Despite its drawbacks, I'll still put this power supply to good use.